Hi guys, my name is Greg Friedman. Welcome to my channel where we review scientific papers together with you. I learn and I help you learn, I hope. If you like it, subscribe, leave a comment down below and click the little bell icon so we can see each other more often. So anyway, I continue to be on this environmental kick, and in today's paper we're going to look at the air that we breathe. Natural and volatile PFAS in indoor air. PFASs are a class of fluoropolymers that are known as so-called forever chemicals, and they contaminate our environment and looks like they cause a lot of problems. So in this paper in Environmental Science and Technology Letters, the authors look at air as the source of this environmental contamination. And you see they have children in the pictures here. So they actually look at carpets, air, and all of that in kindergartens and classrooms and offices and storage spaces. Kind of scary stuff. So the authors mention that the sources of exposure of per and polyfluorinated alkyl substances, PFAS, include food, water, and given that humans spend typically 90% of their time indoors, air and dust. I didn't think about air and dust. The conversation has always been about municipal waters for me and soil contamination, because that is where the military thinks the problem comes from. But what about air and dust? It's all over the place. Anyway, so let's look into it. Volatile PFAS, specifically fluorotelmer alcohols, FTOHs, are ubiquitous in indoor environments. For example, California kindergarten, the concentration was 9 to 600 nanograms per cubic meter of air. That's a lot of air, but that's a lot of nanograms. So in this paper, we'll look at carpets, dust, and air as the major sources of PFAS. Diet, water, but the authors look into air. So the authors actually use a very interesting way to detect these PFASs. They take polyethylene sheets, just a sheet of plastic, put it in the room and wait for a bit, and polyethylene absorbs these fluorocarbons, and then the authors are able to measure it using pretty sophisticated techniques. I will, of course, as usual, leave link to the paper down in the description. Please take a look at it yourself. This very interesting paper. I'll skip over a lot of the details. The authors analyzed 90 samples in total in all sorts of different locations. And typically the study was done in almost a month, 14 days to a month. The samples were analyzed by gas chromatograph coupled to a mass spectrometer. Good system, solid data. Lots of details. I don't think they're very necessary for us. The authors analyzed 25 and 50 micrometer thickness polyethylene sheets, but the results were about the same. So specifically, authors looked at California kindergarten classroom, offices, classrooms, and laboratories at the university, storage room in an outdoor clothing store in California, and a couple of other locations, I think. We'll look at the table. And here's the data. So we see kg, 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 kg. All of these are kindergartens. H1, home. Someone's home. Lab, office, elevator, storage room, classroom, and different locations in an outdoor clothing store. Cool. So this is pretty much where we hang out, right? Most of us drop off kids at the kindergarten where they hang out, and then we go to the office. And maybe we shop for some clothing. And take a look at that. This is concentration in nanograms per cubic meter. It's kind of all over the place. What's very interesting for me is different kindergartens, or different locations in a kindergarten, I guess. Some are very near zero, like right here, and some are in 600s. And like this office is over 1,000. I think that's the detection limit. But the two offices next door and the office in the other door have 0. Do they filter the air? Do they vacuum the carpets? What? I didn't find in this paper what this difference is between those offices. That's kind of curious. And in the clothing store too, these different chemicals, they're looking at 6,2, FTOH, 8,2, FTOH, and others. There is significant difference between these. And it looks like the method is pretty sensitive, going into, hundreds of nanograms per cubic meter, up to thousands, and we see a drastic difference. I want to know the cleaning procedure difference between the clothing store and the office. That's just me. I'd like to be in Office 4, Office 5, or Office 2, not Office 3. That's off the charts. Maybe different carpet. I don't know. That's part that's really missing from this paper. That's very interesting for me. This graph was pretty confusing for me. Percent of volatile and neutral PFAS and indirect or biotransformed PFAA, top and bottom panels. But where is dust? All the measurements are in air, and they're tiny, tiny little blue, barely visible concentration in dust. So the authors estimated daily intake, EDI, total EDI in supplementary tables. It was ranged from 1.5 nanograms, 14 for intermediate, and 150 for high exposure. I'm not sure what low, intermediate, high exposures really mean. I'm guessing this would be low, this would be medium, and this would be high. Not sure. This paper is a little bit confusing. Maybe I didn't spend enough time reading it. It does leave more questions. The important thing for me, volatile and neutral PFAS measured in air contributed to 5 up to 62% of the total intake, while ionic PFAS measured in dust contributed to 34 to 95% of intake. As opposed to food and water, this would be pretty major. So we're trying to fix the wrong thing. We're fixing water instead of fixing air. Maybe we should look into air filtration. Maybe I will. So the authors claim that their results imply that air inhalation was major exposure pathways for the volatile fluoropolymers, while dust ingestion was dominant for non-volatile. In children, they estimate indirect exposure to be from 1 to 3,000 nanogram per kilogram of body weight per day. Cool. So 3,000 nanograms is a milligram. No, microgram. 3,000 nanograms is a microgram in a day. It adds up. It adds up. And given that these forever chemicals stick around in our bodies, this is a great paper. Read it for yourself. Again, I'll leave the link down in the description. Subscribe. I will definitely come back to this topic more and more often. I'm very curious about these fluoropolymers, and I look forward to reading more about them. If you have questions, please don't hesitate to leave them down in the description below, or below the description. Anyway, you know where to write comments. Peace out, guys. See you in the next one.